Welcome to the NAHA webinar, brought to you by the National Association for Holistic Aromatherapy. To learn more about NAHA, please visit www.naha.org. Tonight's presentation topic is Olfaction and the Honeybee. This educational webinar is being presented by Amanda Plunkett. After years of suffering with an environmental illness, Amanda turned to holistic medicine. She began her aromatic education by obtaining her advanced aromatherapy certification with the School of Aromatic Studies in 2015 with over 500 hours of training. Since then, she has also successfully completed a horticultural class and gained an organic lawn care accredited professional certification through Chip Osborne. The wide range of training emphasized how health starts with soil. In 2016, Amanda launched Be Rooted, a company dedicated to advocating for healthy environments. As an environmental illness survivor, she feels she has a special relationship with bees as they too are sensitive to environmental changes. She uses her experience to spread awareness for healthier environments, develop self-care products, mentor environmental illness survivors, and naturally care for pollinators. To learn more about Amanda, please visit her website at www.berooted.com, and that is spelled B as in the bumblebee, rooted, ROOTED.com. And I'd like to just take a moment and welcome Amanda for being here this evening and speaking on this incredibly important topic for anybody in the aromatherapy, herbal, or gardening world that works with plants, that consumes plants. This is important. So thank you for being here.
Thank you, Kelly, for the invitation, as well as thank you to the National Association of Holistic Aromatherapy and for allowing me to give this presentation. I hope all enjoy learning about olfaction and the honeybee. From 2013 to 2015, I spent those years healing from environmental illness and trying to find my voice to speak against the dangers in my environment. I felt as if my efforts fell on deaf ears. In 2016, I launched Be Rooted to serve as a vehicle for advocating for sustainable and healthy environments. Just a few months after launch, I received an invitation from the Citrus Valley chapter of environmental health specialists to speak on the decline of pollinators. Since then, I have grown Be Rooted to work with dozens of organizations, and I continue to provide professional and volunteer education to the public. Honeybees serving as celebrities were the mascot I needed for my voice to be heard. A huge part of what we do is relocations of nuisance colonies to community gardens and backyards in SoCal and education of the public. As a beekeeper, the primary question I am asked is, are bees really becoming endangered? The question is complicated. This chart was extracted from Bee Informed. As you can see, in 1947, there were 6 million managed colonies being reported to the federal government. At this time, there was no internet. Cities were often rural. Many rural communities had lots of individual farmers who had individual colonies. This means that this 6 million managed colony number is likely a lot lower than the reality. In 2016, we had 2.5 million managed colonies being reported to the U.S. federal government. At this time, we now have the internet and easy access for backyard beekeepers to register their hives. This means that this 2.5 million number is likely much more accurate than the number from 1947. Thus, there has been a steep decline in honeybee populations in the United States. However, Since honeybee populations can be artificially increased through significant splits and commercially raised queens, numbers have begun to stabilize. Therefore, honeybees are not yet at risk of becoming endangered. The real issue at hand is the significant declines in overall populations of insects, especially pollinators. In 2014, the United Nations issued a report that they believe that over 40% of our invertebrate pollinators species, such as bees and butterflies, are facing extinction. They also said that they believe that over 16.5% of vertebrate pollinators, this would include our birds, are also facing extinction in the next few decades. In 2017, Germany issued a citizen scientist research project result from the study that occurred over 27 years. These were in areas that were protected. These were sanctuaries throughout Germany. What they found over 27 years is that 75% of their insect biomass had disappeared. Think about that. That's the basis of the food chain. The area around the sanctuaries had not changed drastically in habitat. What had changed drastically was the increase in the use of pesticides. In the United States, we need to focus more on native pollinators, such as our native bees. Honeybees, due to commercial concerns, are often used as a cornerstone species to monitor pollinator declines. However, they are immigrants to the United States and are actually native to Africa, Europe, and Asia. They are usually the celebrities, but there are over 20,000 different bee species worldwide, and over 4,000 native bee species in the United States. Whereas honeybees are generalists, meaning that they can pollinate and they can forage and gather pollen from many different flowers, most of our native pollinators are what we call specialists. This means that a particular plant may only have one particular pollinator, or on the other hand, a pollinator may only have one particular plant. This chart was extracted from pollinator.org from a planting guide for the region of Southern California. What you see at the top is a listing of our native bees: bumblebee, digger bees, large carpenter bees, small carpenter bees, etc. What you see along the left-hand side of the table are plants that are recommended for my area. If you look, you can see that columbine is only pollinated by the bumblebee, or that passion flowers are only pollinated by the large carpenter bee. This means that many people in my area will have passion vines with lots of flowers and no fruit, because they do not have the habitat needed for the large carpenter bee. This has a far greater impact than just on our agricultural crops. It actually impacts the entire system. If we lose specialized pollinators, we also lose the plants and habitat that go along with them. To learn more about native bees, the USDA Forest Service and Pollinator Partnership has made a great ebook that you can download for free. The link for this ebook is included in the resource section at the end of this presentation. In this ebook, you can see that there are many different habitats for our native pollinators. 70 to 80% of our native bees are actually ground dwellers. So when we are talking about saving the bees, we need to save the soil. We need to build for them plants and homes. Native bees also often overwinter and go through metamorphosis in messy gardens. Bumblebees love wood and leaf piles. Leafcutters love old wasp nests and dead canes. Leave a messy garden for our native pollinators. Forage diversity has been shown to increase the resistance of bees to stressors. We can all do our part in helping to improve honeybee and pollinator nutrition. Planting hedgerows on monoculture farms has been shown to increase diversity and increase pollinator populations. But what can we do as individuals and as a collective here in our cities? Trees provide the most forage per square inch for pollinators. The University of California Extension recommends watering trees during the drought, even if you don't water anything else, to keep the trees healthy, because they are not only a primary source of forage for our pollinators, but they are also essential in habitat to many other species. Weeds are often bee favorites, especially dandelion, clover, and mustard. Often in the spring, dandelion and wild mustards are the first forage for bees and help bolster spring colony growth. How do we view weeds? In my garden, I actually cultivate purslane and dandelion. As a beekeeper, I smile when I see the mustards bloom. As organic community gardens begin to grow in our cities, do we support them through our volunteer efforts and donations? Do we encourage local sponsorships and community gardens and help with their publicity? Do we provide open space and habitats where beekeepers can house their hives? For great resources on plants for your specific area, download the Eco-Regional Planting Guides from pollinator.org or download the Pollinator Partnership app. Xerces.org also has free recommended plant lists for native bees, honeybees, butterflies, moths, and hummingbirds as well. Another great way to help pollinators is to encourage organically managed land in our cities. We are exposed to a synergy of pesticides when we eat, when we play at our parks, when we go to school, and more. Our pollinators have no safe spaces. The general public is increasing their desire for organic methods. For example, the city of Irvine switched to an organic landscaping policy in February of 2016. Since then, the city has managed more than 570 acres of parks, 800 acres of right-of-way, 70,000 trees, and nearly 1.5 million square feet of facilities without conventional pesticides. I am partnered with non-toxic communities and Beyond Pesticides to help cities move to organic pest management. Contact them to help you find a local group in your area and find out what you can do in your HOAs, schools, and cities. On to the aromatherapy part, the actual olfaction. The scent of a flower is a mixture of many volatile compounds that varies with respect to genotype, stage of development, and local environmental conditions. As we know, plants release organic volatile compounds, which are secondary metabolites. These fragrant compounds are then often extracted and used in aromatherapy as essential oils. The purpose of these compounds serve multiple purposes for the plant, but flowers use them to entice pollinators for reproduction. Although other environmental concerns have been extensively studied, one question that is gaining traction is air pollution affecting pollinator foraging? This is where the study of olfaction is essential. There are various factors that can impact the evaporation rate and degradation of secondary metabolites. One factor gaining traction is the impact of pollution on the ability of pollinators to find forage for food. Some air pollutants interact with and break down some plant-emitted scent molecules at greater rates. This happens as chemical interactions decreases both the lifespan and the distance the scent is able to travel. This means greater foraging time for pollinators, the reduced ability to find food, and increased pollinator energy used. The next few slides come from one study studying the impact of pollution on volatile compounds in plants. Through modeling, researchers have found that alpha-pinene, a primary component in rosemary, Rosmarinus officinalis, survives 40 hours in an ozone-free environment. Different pollutants degrade flower volatiles at different rates. Thus, alpha-pinene survived only 10 hours at an ozone concentration of 60 parts per billion and 1 hour at ozone concentration of 120 parts per billion. To put this in perspective, the average ambient levels of ozone measured at nearly 250 sites across California for 1 hour ozone measurements was 51 parts per billion from 1998 to 2000. This means that the 60 parts per billion at which alpha-pinene survived only 10 hours was generally close to the average for California. National standards for vehicle emissions, such as close to highways, is 125 parts per billion, which means that pollinators only had 1 hour to find alpha-pinene for forage. Researchers also found that Betamercine is a primary component of bay laurel and travels more than 3,000 feet in an ozone-free environment. At the average 60 parts per billion, it traveled only 1,000 feet, only 1/3 of the original distance. So we've discussed length of time the volatile can last in the environment. We've discussed distance. And now we will discuss how long it takes foragers to find the food. The results of this study also showed that in an ozone-free environment, it took 10 minutes for foragers to find scent molecules, beta-carotene, which is a primary component in clove bud essential oil. When the ozone rose only to 20 parts per billion, not even close to the California average, it took 180 minutes. It went from 10 minutes to 180 minutes. This means that foragers would spend 18 times longer trying to find food rather than taking food back to their offspring. The oxidative degradation of the VOCs emitted by flowers may reduce their concentration in an odor plume, decreasing the distances they can travel before reaching concentrations that are not detected by foraging pollinators. Moreover, the reactivity of the individual VOCs in a blend differs both with the properties of the chemical and the properties of the oxidizing agent. Therefore, VOCs in a chemical blend may be degraded at different rates. All processes involving the reaction of ozone with VOCs may reduce the intensity of the floral smell and provide significant additional variability to flower olfactory signals once they have been released. potentially with negative effects on the reliability of floral scent as an attractant. In this chart, at the top, you can see OH, hydroxide, O3, ozone, the unstable triatomic form of oxygen, and nitrous oxide. On the left, you see camphene. Camphene exists in all eukaryotes, ranging from yeast to humans. It is in foods such as dill, caraway, hyssop, and fennel. It is also a minor constituent of many essential oils such as cypress, camphor, citronella, neroli, ginger, and valerian. Excuse me. Alpha-terpenine is also a constituent of many essential oils such as citrus and eucalyptus, juniper, cardamom, and marjoram. Beta-carotene is present in cloves, black pepper, rosemary, and sweet basil. Alpha-citrate is a primary component in cedar. As you can see, there are varying results. Alpha-terpenine, for example, which is one of the components that we used in a study over the summer to train honeybees to a scent, degrades in 23 minutes with one pollutant, and it only lasts for a minute with ozone. This is the reason why we use this component, is the quick degradation in ozone so it wouldn't blow away with the wind. The results of the study show that the combined results of chemical analysis and behavioral responses of pollinators strongly suggest that high ozone concentration have significant negative impacts on pollination by reducing the distance over which olfactory signals can be detected by pollinators. In this study with Gerard, there are many different monoterpenes released over many different distances the measurements were taken. The baseline at 0 shows that the monoterpenes did not degrade at the site with no ozone. However, the degradation was impactful over 80 parts per billion and 120 parts per billion. This was a monoterpene blend. And you can see that at 80 parts per billion, which is close to the California average, the degradation was up to 20% for a distance of only 4.5 meters. Anisaldehyde had also the same results. Simply put, what does all of this data mean for our pollinators? In low ozone areas, foragers can easily detect scents to find food. In high ozone areas, pollinator scents break down or get altered, and pollinators cannot detect them at greater distances, expending more energy to find food and bringing less food back to the offspring. Most studies training bees to detect scents are in labs using restrained bees in harnesses trained to a scent with sugar water reward and using modeling mimicking real-life scenarios. I received the privilege this last summer to support a preliminary research study on this topic with free-flying bees in ambient real-life conditions. We trained bees to find alpha-terpenine, a scent molecule in cardamom and marjoram. The open bottle of this scent could be detected by our human volunteers around 100 feet on low ozone days. On high ozone days, the volunteers could not detect the scent less than a foot from the sample. And methods were being developed. No data on the results are available at this current time. However, I just wanted to highlight even the low-tech method showing the impact of pollution on olfaction in humans. We'll now discuss the importance of olfaction in hive functions for honeybees. Specialist pollinators generally hone in on a limited number of flower scents from their specialized plant to find food. The honeybee is a generalist, detecting a myriad of flower scents, and has been used as the main research subject to study pollinators and olfaction. Apis mellifera, the honeybee, has been a central insect to study olfactory perception and learning for more than a century, starting with the pioneer work by Carl von Fritsch. Honeybees have over 60,000 olfactory scent receptors in their antennae, with over 170 different types. Unlike humans, they can detect odor molecules at parts per trillion versus parts per million. They have been trained to detect bombs, cancer, diabetes, illegal drugs, and more using the proboscis extension reflex protocol. Often, the study of human olfaction and the brain is quite complex. Humans have over 400 different types of scent receptors. With only 170 different types of scent receptors, researchers have found that honeybees offer insight into the human brain through the connection with olfaction, and use such research to study human health and behaviors. For example, studying honeybee olfaction has helped researchers understand epigenetic changes due to olfaction in behavior and memory, and the effects of pollution on health. Olfaction cues are essential to hive functions. For example, the queen releases different pheromones from her mandibles. The queen mandibular pheromone lets the workers know that the queen is alive, present, and functioning. After all, she needs to lay 1 to 3,000 eggs a day. The retinue pheromone attracts attendants to her to groom and feed her, as you can see in the circular pattern on the image. I train my students to look for this behavior in their hives when looking for the queen. A honeybee has a barbed stinger which detaches from the bee with the elasticity of mammalian skin. This releases isomyl acetate, which smells like bananas. This triggers other guard bees near the hive to sting to defend the colony. My saying is that bees are not aggressive, they are defensive and will defend their home. Oftentimes, lavender will relieve a honeybee's sting, so I keep Lavandula angustifolia on hand for relief. Also, plantain or lemon balm poultices help as well. There is a misconception that lemongrass essential oil smells like the queen because it attracts honeybees. Rather, worker bees release the Nasanov pheromone from the backs of their abdomen. This pheromone contains the isomers of citral, neryl, geranyl, nerolic acid, geranic acid, and farnesol, which smells like lemongrass. This is actually the welcome home or come this way pheromone that workers release to attract their sisters. Beekeepers use lemongrass essential oil, a drop, in a box, as a swarm lure to attract colonies. Tea tree oil, often used as an insect repellent, can be used in higher amounts in smokers to repel honeybees from an unwanted space, such as when I do relocations. However, it is also used in lower amounts in recipes to prevent the impacts of mold and fungal diseases. Beekeeping goes back throughout history for thousands of years. It was related to goddess worship in the ancient world. Bees are a matriarchal society dominated and managed by women. The name Melissa comes from the Greek word melissa, bee, which in turn comes from meli, or honey. The Order of the Melissa were priestesses to care for bees at Aphrodite's and other goddesses' shrines. Interestingly, honeybees love to pollinate melissa. I have grown and used the dried herb in my smoker as a calmative for honeybees. As such, it is highly calmative to humans as well. Since the honeybee brain offers insight into how memories form, how the memory changes with age, how olfaction impacts behavior, and how olfactory input affects social cues, it has been shown that this importance in using the honeybee and brain plasticity in research led Monash University in 2015 to open an entire lab to study the honeybee and the implication it has had in neuroscience. Honeybees offer great insight into the way the human brain works. For instance, honeybees use memory to find their way back to pollen-laden fields, and they communicate in sophisticated languages to tell other bees about danger and new sources of food. The importance of the honeybee to neuroscience has led the university to open a completely unique facility focused on the study and the behavior of bees and what they reveal about the human brain. The advantage of having a honeybee laboratory is that behavior and brain plasticity can be examined in a controlled manner. Bees emerging from the same brood frame in the hive are exactly the same age, so their exposure to the environment of the hive is controlled during the first 2 weeks of adult development. We'll get into something a little more in depth now. Your genes may not be expressed. They can turn on and off. This is called the study of epigenetics. Epigenetics are affected in utero, in childhood, and adulthood by environmental chemicals, drugs, general aging, diet, stressors, and everything we're exposed to. Honeybees have very streamlined genetics with fewer genes than almost any other species. Yet they are highly sophisticated in their behavior, capable of colonial loving, hive development, nest cleaning, and communication. The lack of gene diversity with a combination of highly sophisticated behaviors leads to researchers being able to tie specific genes to specific behaviors, and that could be equivalent in the human brain. Monash University is also studying honeybee epigenetic expressions. Epigenetics is the study of heritable changes of expressions of genes without the actual alterations of DNA sequences, turning that DNA on and off. These expressions control disease development and behavioral development. Research has found that not only can our emotional experiences shape our epigenome, but dietary and other environmental factors induce epigenetic alterations which may have important consequences. How does this apply to aromatherapy? Beekeepers have long used herbs in their smokers, such as melissa and lavender, to calm honeybees. 2 new research papers from Monash University researchers reveal the way the honeybee controls aggression and forms memories. The discoveries have important implications for the way the human brain controls aggression and forms memories, and loses memory with age. The researchers found that regular exposure to lavender calmed honeybees by not masking alarm pheromones, which was the original assumption, but instead by changing epigenetic expressions which modulate the aggressive behavior. And actually, this exposure switches the response off in the brain. One of the researchers stated, "Due to our new research, we now know why it works as a calmative, including for humans and their pets." Our team, colleagues from Australia and France, examined how lavender and other key odors modify honeybees' aggression when they defend their colonies against intruders. The odors counteract the potent alarm pheromones that bees release to recruit nestmates in defending the hive, thus reducing overall aggression. The research showed that the aggression expression was turned off. Such research may have huge implications in future research on olfaction and the impact of what we take in through olfaction on our epigenetic expressions, which then affect behavior and memory. In addition, we may learn more about mental health illnesses, autism, and other neurologically impacted illnesses by studying olfaction and the honeybee. Studying pollinator olfaction helps us to understand human olfaction as well. The role of the olfactory system is to detect molecules in the environment and use that information to allow the animal to make decisions and engage in adaptive behaviors. Major tasks of the olfactory system are to identify food sources, detect dangers, find potential mates, and guide social interactions. Olfaction, or our sense of smell, is often taken for granted. Although humans can detect over 1 trillion scents, we often do not trust our nose, which has over 5 million olfactory receptors. Yet, olfaction, tied into the very primitive part of our brain, the limbic system, controls stress responses, memory development, hunger, habit behaviors, caring for offspring, and other physiological and psychological behaviors. I have included the resources from this PowerPoint into a list for download. I want to thank you all for listening, and I hope you enjoyed the presentation. I want to thank the National Association for Holistic Aromatherapy and Kelly for being a fantastic co-presenter.
Well, thank you so much, Amanda. This was a wonderful, amazing webinar. And this topic, I love it. And I know that the NAHA members will appreciate it. And I also hope that it will bring about a newfound appreciation for bees and fellow pollinators, especially for anybody viewing this video and recording later on. So thank you so much. And I'd like to remind those that listen to this webinar, and if you like this webinar and want to check out more information about Amanda, to please visit her website at www.berooted.com. And for access to other NAHA webinars, educational webinars on aromatherapy topics, you can join NAHA to get access to that, or you can purchase the webinar recordings from the NAHA bookstore at www.naha.org. Thank you so much for being here.